Good afternoon, everyone. Sorry for this short delay. So I thank Sachin and team for inviting me and giving me a chance to make this presentation. We have been working on this aspect of how IoT technology can be used for smart cities. And today I want to give you a specific perspective we have been working with, which is a perspective from the data side. So if you would like to connect with me after the talk, please feel free to send me an email at the email address I've indicated at the bottom. So there are 4 sections to this talk today. I'll go over the motivation and the context in which we are working, and I'll share with you our perspective and the test bed we are working on, and conclude with some closing remarks. So as you all know, the Indian government has really put this concept of smart cities right up there as one of the important aspects for us in the next few years. And if you look at the smart cities website, the government website, which I've indicated in the bottom here, they identify a few features which they think are important for smart cities, related to how we can use land in diverse heterogeneous ways, make it inclusive, have inclusive housing for people. Walking is a big important focus. Develop open spaces, multimodal transport, make governance easy, citizen friendly and cost effective, and try to develop a unique identity to every city. And finally, apply smart solutions to infrastructure and services. So the reason I kind of bring this out is that as technologists, we are very focused on technology, but cities are of course more than technology, and there are many aspects where ICT need not necessarily play a role. But nevertheless, ICT technologies are going to be very critical to help develop sustainable and cost-effective government services for the citizens, as indicated by the last point. So again, in the same website, if you dig around, you'll find an analysis that has been done based on the requirements submitted by about 20 or so cities, which were shortlisted in the first round. And what you see out here is basically the components which are kind of common across many of the submissions. I'm not going to read out all of them, but it's kind of just interesting to have a look at some of these components. For example, the most important requirement from most cities seems to be a way to have a global and common perspective of what is going on in the city, and they kind of call it the centralized command and control center. Mobility is again a big requirement with this requirement of transit operations, and parking again seems to have emerged as a big pain point for many cities, and they would like to have a better way of managing parking, and so on. Water, surveillance, emergency response, etc., etc. So what is interesting out here is that, if you kind of go ahead and start thinking about, realizing these components, of course, one approach is to kind of take each component as its own independent silo and try to implement it. But, one could kind of find, for example, from an IoT perspective that, there is a possibility of using the same IoT device for multiple of these components. And that is a point I want to come back to a little later in the talk, because that is very important from the architecture perspective, right? So that we don't get stuck in silos. And a street lighting system is only doing street lighting and not doing anything else. So a very important sensor from this particular list of components turns out to be the camera, because a camera is really diverse and you can use it for many different sensing applications, not just for surveillance. We also had opportunity to interact with a couple of city administrators who are involved in the smart city activities. One was in the city of Chandigarh, where we had organized a workshop sometime last year. And the other has been a smaller township called Electronic City, where we have been interacting with the CEO of that particular township. And it was interesting to, of course, it's just 2 data points, but it was just interesting to kind of understand what their requirements are beyond what they have already indicated through the proposal documents. So it was kind of good to know that they insist that citizens must be the key beneficiaries for any smart city solutions, and all status of society has to be benefited by that. And of course, they reiterate this ability and the need to be able to have a complete visibility as to what's going on. Because I guess there's a lot of lacunae of information and data right now for them. And they also want to be able to, they are very cognizant of the fact that long-term, whatever solutions are there have to be low cost and sustainable. And it is interesting that they kind of mentioned that smartness has to be built into that system. So essentially to help them, the machines and the algorithm should help them to do a better management of the city. Another interesting point they brought out is that the solution should be vendor agnostic, and they said both hardware and software. It would be ideal if both of them are replaceable and we don't get locked into a specific vendor. And kind of looking into the future, they also kind of said that these platforms should enable future smarter intelligent solutions. So to me, that was very interesting to hear this kind of a perspective from these city administrators. As we kind of studied this aspect further, what was pretty apparent to us was the siloed approach, and that is, I guess, this observation is shared by many people. For example, the surveillance solution will be implemented end-to-end by a group of companies, I guess, led by some particular vendor, where the cameras get installed, and then you have a nice command and control center to view the information from the cameras. But then being able to access the data from the cameras is really difficult in this kind of an approach. As I mentioned earlier, that the same camera could be used for many different applications. You could use it to look at perhaps whether parking is available or not. You could use it for that, for example. And with the current way of doing the implementations, that seems to be really difficult and not possible to use. So, so essentially, what is happening is that the point solutions are leading to silos, and you are not able to reuse the deployed resources, both hardware and software. And so we kind of started thinking about that. And this is something which is, of course, pretty, in some sense, well recognized, is that you probably need some kind of a horizontal architecture. And while we can have various reference architectures, we also, I guess, need to have reference implementations where we can really explore many of the ideas as well as understand the limitations of different approaches. And then there was this issue about, what is India specific about this? Can we import a technology from Europe or US and just put it out here? What are the things? Are there what aspects are specific to Indian conditions? So that is something which was also being asked. And another aspect which was kind of pretty noticeable was that there's no really a place to do interoperability testing right now. Right? So we need some kind of a test bed, and that is kind of something which is missing. And finally, we have been kind of pretty focused on the requirements expressed by the cities currently. Right? What is their need? And we have a long way to go. We have a lot of lacunae right now in Indian cities. But what about new applications? New future applications? Do we have support for those? I want to kind of illustrate a few example applications from different perspectives, right? 4 different perspectives. And you can come up and think of many such examples in the future. For example, a citizen can ask, can you give me a route which is safe to walk and will not worsen my allergies? Like, can you solve that particular problem for the citizen? Or the police can say, look, I'm not able to take a good picture of the vehicle's number plate. You have all this smart street lighting system. Can I use that as a flash and get a better picture when I need it? Or say you're stuck in traffic and you're getting frustrated And instead of something leading to road rage, what if you could actually access a camera downstream which tells you what is happening actually, so that you can calm down? Or let us say you enter a nice shopping street, like for example in Bangalore we have this DVG road, a lot of shops. But what are the deals available in the shop right now? Is there a way to get hold of that information? So just to illustrate, these are some of the kind of potential new applications which I could think of. I'm sure the other people will be able to think of even better ones and more useful ones as we go forward. But the question is, how do we support? Do we have an infrastructure to support all these applications? And if you see out here, to answer and support all these applications, we really need to be able to manipulate the data and the system in a way so that these answers are given to these different stakeholders. So, so that kind of led us to kind of really focus on data as the key aspect, and keep that in the center of our explorations out here in IISc. So our vision of a smart city IoT framework is basically around data, and we have this hourglass structure which is inspired by the Aadhaar architecture. Aadhaar is this unique identification system which is right now used in India to identify all the residents in India. And so here what we basically are focusing on is that the data, which is the key, is in some sense the center, and it's the neck of the hourglass. And can the system manage data and decouple the producers of data from the consumers of data? And essentially make it easy to both produce and push data and also consume data. So all the sources of data, like the IoT devices, for example, cameras, lights, meters, etc., including virtual sensors. Right? You could have apps which act as data sources, crowd data, etc. All these are able to push data into this horizontal layer, and then all kinds of applications pull data out of this horizontal layer, as opposed to a lighting device directly communicating with a lighting control app. It communicates through this data layer. And with this, you can come up with new applications which actually combine data from diverse sources. For example, in the case of the traffic police wanting to use the streetlight as a flash, you can do that if both the streetlight and the cameras are connected to the same data layer. So we would like to focus on data and APIs, and clearly this is something which has to be extensible and scalable. Extensible in the sense that you should be able to add new and new data sources, new ways of accessing the data, and it has to scale to the kinds of data which can get generated in cities in India. And of course, security is really critical, and privacy, especially in the light of the new judgment from the Supreme Court, where they have said privacy is a fundamental right. Again, that is really important to be able to preserve privacy. And such a system, of course, should be sustainable and maintainable in a way which is low cost, right, without having to put in huge amounts of money. And what that means is that we need to have a large body of people who are educated in the technologies which go in. So we have enough manpower, specialized trained manpower available to help extend, maintain, and scale such solutions locally in India. And again, as something like this should enable new cross-domain applications, especially applications where real-timeness is important. Because many events in the city are only relevant in a very limited spatio-temporal context. What happens in my street is of importance during that time for the people around that street. Like, it may not be important for people out there somewhere else in the world. So, and also, so there is a certain temporal relevance and spatial relevance to information and events which happen in the city. And finally, a kind of a wish list is ideally a device or an application which works in Bangalore should work in Chandigarh, should work in Shimla, should work in Ladakh, wherever. It should be portable, right? I don't have to kind of retune the device or retune the applications. So that is kind of the ultimate holy grail in some sense we would like to have. So at this point, I would like to kind of bring in our perspective on managing data and devices. And here we would like to separate out data management versus device management. And I kind of mentioned this in the context of the 1M, 2M, and other standards which are emerging. So we have, so from a city's perspective, data is, of course, the most valuable thing. And it is something which will enable new services as well as possibilities for monetizing the data. Of course, the devices are important. They produce data, but managing of the devices is a very specialized task. And you can have specialized companies which handle and manage the devices. From an administrator's perspective, of course, what is important is certain parameters of this. Perhaps is the system healthy? Are the devices working? If they're not working, whom to call? If something, things like that. Not necessarily the detailed aspects of the devices, which are of more interest to a technically qualified person who's responsible for managing the devices. So that is why out here in this diagram, we show how you have this cloud of devices sending data to the data middleware and applications getting data from the middleware. And then you have the management system, which is managing the devices, but reports specific things. The management system itself supports and generates data, alerts, alarms, etc. to the city, which is of interest to the city administrator. So if we kind of dive down into the data middleware, so we basically have kind of come to this particular view of the middleware as to what are all the services the middleware should support. And it consists of the following pieces out here. There is a piece related to, of course, the AAA system, authorization, authentication, accounting, which is really critical. There is a piece related to a catalog, which is equivalent, which is basically a directory. You want to know the directory of information resources which are available, which are sitting behind the middleware. And I'll kind of go into more detail on that particular aspect. You want to be able to get live data where the data gets just disseminated through brokers where you're subscribing to the data. Of course, you want to have access to archive data, and then you want to have, cities are very spatial, right? So you need to have access to GIS information. And finally, video is a very special case. It needs its own system, and video is really critical, right, for many of the applications. So you need to be able to also access video and manage video. This particular middleware, we think that accessing the middleware will largely be done through applications. So API access is really critical, and so the REST APIs have kind of become the de facto popular way of accessing information. And so this particular middleware has, you can access the middleware through REST APIs as well as streaming APIs. Now that sources of data, which could be various IoT devices as well as various applications. What do I mean by application? Just to kind of give you an example, let us say you have a video surveillance system, a camera system, and you have a small video analytics which is running, which is a piece of software which is looking at the video data and then raising alarms and alerts. So that becomes a kind of a virtual sensor which is pushing data into the system. Now these sensors and these devices could be on, of course, IP networks, but also non-IP networks. And the example of non-IP network is, of course, you have LPWANs like LoRa, and you have SCADA systems and so on. And so to be able to access these, you would need adapters as required, to be able to speak that particular language. And on the northbound, you have the applications which are feeding off this, including command and control, city, business processes for the city, new applications, etc. So I want to kind of take a few slides to go into this catalog. This catalog is kind of is basically a directory, and this concept has been proposed as and standardized as HyperCat by the British Standardization Organization. So we kind of looked at it. We really like the concept, but in our particular implementation, we kind of have deviated a little bit in the way we are representing information and so on, but the idea is basically the same, and I'm sure there are similar things done in some of the other information systems. The point of the catalog is essentially for a user to be able to know what are the sources of information and what is the meta information about that sources. What does it, how to interpret the data coming from this, what are the formats, etc. And of course, you should be able to access this through REST APIs. So the way the information is stored in the catalog, which is there in the center, is kind of dictated by a schema. The schema for every item in the catalog essentially is like we can think of it as a grammar, which kind of checks and kind of puts a structure to the data which is stored in the catalog. Now, what is the information stored in the catalog? It's information about a particular information resource. For example, it could be a street light, parking sensor, etc., etc. And that information can be kind of thought of as 4 different, belonging to 4 different categories. There is some static information about the device. We'll see. We'll go into a specific example soon. But information about the ID of the device, where it's located, and certain other kinds of information which is static, which happens once when you onboard the device. And when the device sends data, you observe, basically. You are observing that device. So that's the observation schema. The data comes according to a particular format, and that is the observation schema. And if you want to control the device, there is a control schema. When you send information to the device, you send it in a particular format. That is the control schema. And then there is a configuration schema, which is related to configuration of the particular device. Now, what I show out here is that, there is a schema for a device, let us say Streetlight. When a specific instance of the Streetlight gets registered in the system, it kind of puts its own information, which gets validated against the general schema for a Streetlight. Now, when the device onboards its own information, it can point to any schema, right? And here, as we'll discuss in the next slide, we're using JSON schema as the format, as a method for encoding these schemas. So once a device onboards itself, it registers with the system and says, this is the way in which I'm sending information. That is observation schema. So when any observation data which comes from the device and gets pushed to the application gets validated against the observation schema. Similarly, any data which gets sent to the device, for example, as a control, gets validated against the control schema, and so on. So this is in the catalog, what we have is basically the schemas of instances of the devices, which are actually available to the middleware as sources of information and which you can control. So if we were to go into the schema itself, the schema of the format in which the devices send information. So as we said, we are basically using JSON schema as a way to describe these schemas. And I'll not highlight all of these points, but what this document shows is a structure of the items which are stored in the catalog. So what this is saying here is that the item in a catalog contains the following fields. For example, there is an ID field. ID field is of type string, and it describes a unique identifier for the device source. And it is according to the schema which is used to describe itself is shown out here, and it has a unique identifier and so on. And then it has an owner. There is an owner for that particular resource. There is a provider who actually sets up and manages that resource. This is how you would access the resource. And this is these are the various tags associated with the source. The tags essentially give labels to the resource, and it's very useful when you search the catalog. And finally, the observation schema or the data schema from the resource is described in this grammar out here, okay, where it's saying you can have names for properties, names for the keywords. The parameter names can be anything which is alphanumeric and so on, and they again take a structure which is defined out here. So now what happens is that, again, going back to this picture in the back, so you have this item schema, and then we'll now look at the schema of a specific item. And as an example, we have taken the Streetlight. A Streetlight is an interesting example because you get data from the Streetlight, and you can also go and control the Streetlight. So it's a nice example to kind of close the loop in some sense. So this is a specific Streetlight which we have in our lab out here, and it has a unique ID, and this ID is unique within the context of the middleware. And it has certain tags which the provider of the Streetlight can put, and then in what we are envisioning, users can also put tags. You can have, the idea is you can say this device doesn't work, the data of this device is bad, etc., etc. This is a great device, whatever. So you could have user contributed tags, for example. This is the latitude and longitude, and also you can, when you look at these keywords, you can actually give a reference to the ontology out here, so that if you want to later on do further inferencing in an automated way, that should be possible out here. And the owner of this device, the provider, the location, address. And then how do you access this particular information resource? So here, to get access to this resource, you need to get permission. So, so this is whom you contact to get access, and I'll kind of describe later how the access is controlled and what the security mechanisms are. And then the endpoint to access this. Basically, if I want archived information, this is the endpoint out here, and it says the endpoint to access archived values, which is in a database. So you can get values for the last 10 days, 10 hours, last 100 points, or etc., etc. A lot of search, whatever search capabilities are there in modern databases, you should be able to use that. If you want live data, this is where you subscribe to, so that you get live data coming from that particular device. And if you want to go and connect with the device to command the device, this is the update endpoint. And then the information about the various APIs available to access the device is out here. Now the device itself sends data according to this particular schema, and the point out here is that before I continue out here, there are tools available which can take this schema and validate against this specific instance. Right? So those tools are already available. Now within that specific instance, what we have is a schema for the data coming from the device, and that itself is in the form of a JSON schema. And so any data, the observation schema, if you recall from the earlier slide, the observation data can be validated against the observation schema. What the observation schema for the Streetlight is, essentially, it has the following thing. It says this is a sampling instant, data sampling instant, which is sample time in the epoch format. It's units per seconds, and its permissions is read, meaning it is a read-only data, and access modifier, that means it's public. That means this is publicly accessible. A case temperature is the temperature of the device casing. Its units are degrees Celsius. Again, it's a read-only data, and it is visible publicly. So a point I want to make out here is that access modifier allows the owner of the data to kind of set the access conditions. It can be public, that means anyone can access without an account. A protected means you need to have an account and be allowed to access it. And then private means only the administrator can access it. So this way you can control the privacy settings for each element of the data. Power consumption is the power consumption of the device, units is watt. Lux output is units are lumens, and so on. So these are observation data. Now here is the field to control the device. So target power state, it can be a string which can be either on or off, and there's a description of it. And if you notice out here, it's a read-write data and it is protected. That means for you to be able to write this particular field, you need to have the authorization to be able to write that. Target brightness level, again, it's described out here, it's read-write, it's protected. You can have control policy, which is an manual. That means you manually turn on and off. It can be an auto timer based, it can be auto lux based. And if it is an auto timer based, there are parameters out here. That is when it turns on and when it turns off, and so on and so forth. So the point is all these are described as a JSON schema, so that the observation data as well as the control data can get validated against this. And also when you browse the catalog, for example, you can say, to the catalog, you can say, tell me all the streetlights which are in this particular street, and then you should be able to get the list of streetlight, and then you'll be able to kind of see how to access them, what are the data it provides, what are the units of the data, etc. And then you can, of course, add additional links out here if you want to do further, provide further semantic information about these data fields. So every IoT device will actually have this kind of a schema which it uploads into the system when it gets registered. and then the user can then very easily use the data because all the information, meta information about the data is available out here. So, so just to kind of summarize what we have seen so far, there is a catalog which holds information about the resources which are available, and that information is queryable, and it has enough meta information to interpret what is the data, what format it comes, how to access it, how to connect to it, etc., etc. And so it's not only the humans can read it, but also through API access, you can automate the process of accessing information with this. And this, the way this is checked is there is a schema which checks this, and then any live data gets checked against an embedded schema out here. So for that particular Streetlight, if you look at the data from the Streetlight, that is what is shown out here. So this is observation data saying the sampling instant is in this epoch, and the current temperature is 21 degrees centigrade Celsius, if you recall that was the units. Currently power consumption is 0 because it's off. Lux output is 781, ambient lux is 546. And now the system actually, the app sends a control schema, control command to that particular device saying target brightness level is 70, set it in an auto timer mode with an on time and off time. And once the device turns on, the kind of data which comes is different. For example, the case temperature, it has just turned on, case temperature is still about 21, power consumption has gone up to 21 watts. And the lux output, there is an inversion out here, the lux output number has come down, and so on. So, so the data which comes into the middleware is actually a JSON document, but the keywords are described in the meta information, which is entered in the catalog. And this each piece of document gets validated against the data, against the schema which is stored in the catalog. As an example, this is the data from a power meter we have, which there are about 21 parameters in a power meter. It's a 3-phase power meter, and this is a snapshot of one particular document coming from that particular. So, you know, when we look at a city, in the context of a city, and especially if you want to have IoT devices in a city, LPWAN becomes really important. This wide area network, low power wide area network, and currently the available technology for us is LoRa, and it is a non-IP based technology. Now, you know, when you have devices which have an IP address. For example, for the power meter, we can put a small Wi-Fi based module which puts it onto the enterprise Wi-Fi network, and you can actually start, bandwidth is not an issue, you can start sending the JSON documents directly. But when you have a LoRa, and especially in India, the spectrum is really scarce for LoRa, it's only 2 megahertz. So bandwidth is really precious. So, you know, the JSON documents are just too verbose. At the same time, you would like to, but the JSON documents are self-describing, and it's kind of nice, you know, they allow interoperability. But, you know, when you have these devices like streetlights, parking sensors, garbage bin sensors, etc., which are all on LoRa network, you would really like interoperability. When I buy a streetlight from a Philips or a Bajaj, I should be able to just plug and play. Right? I don't need to go to some app and change some app setting. I don't, you know, I should be able to plug it into my system, like what we do with dumb streetlights. So that is the kind of interoperability we need with these sensors, which means that we need them to agree on the common wire or air format. Otherwise, they won't be interoperable. I won't be able to buy just a streetlight from some vendor and plug it in. So, but at the same time, they had to be more efficient, bandwidth efficient. And so that kind of forced us to start looking at how do we encode this data in a more efficient format. And there are many possibilities, BSON, you know, CBOR, etc., etc. But we particularly like the protocol buffer format from Google, and it is, you know, it's open source, it's bandwidth efficient. There is type checking capability in there, and importantly, there is, you know, besides being open source, there are toolkits available for creating client libraries for handling the data, converting the data from protocol buff to JSON, etc., etc. And finally, the protocol buffers offers a way to go towards not just exchanging data, but also exposing services in these end devices. Of course, simple devices like Streetlight, parking sensors, there's not much services to be done, but maybe richer devices and more complex devices, it might be better to go towards an RPC type approach to be able to interact with those devices. So this is an example of the protocol buffer, which is used for the same Streetlight example. So what happens in the wire is that you have these fields: data sampling instant, the case temperature, power consumption, lux output, ambient lux, and there are certain additional parameters. These are all the ties for these parameters, and these are the positions of these parameters in that particular frame, which is a detailed issue which can be looked up. If you look up the protocol buffer, there's good documentation which explains all of these things. So, so something like this should also be agreed upon, so that I can take a device from vendor A and replace it with a device from vendor B. So these lot of these things we kind of have been thinking about and working on in the context of a test bed, because that gives us a concrete thing to work and play with. Otherwise, many of the issues are not apparent. So this is our test bed, which is basically built on smart street poles. And now you see actually many of the cities are actually have put out tenders for smart street poles. And the idea here is that these smart street poles, they are ubiquitous. Wherever streets are, you have street poles, they have access to power, and they become physical mount points for various kinds of sensors and devices. Many of the streets, for example, at least in Bangalore, have fiber running through them. And if you want to have cameras, you need to have fiber. So basically, you have fiber connectivity out here. You have a possibility of putting a small compute module on that particular street. You can put additional sensors like cameras, air quality monitors, etc. And of course, you have the smart street lights out here. And you can have, from our IISc testbed perspective, we are looking to do interpole mesh network, and also you have a low bandwidth, long range wireless network behind out here. So the picture on the right shows a kind of a prototype smart pole, which we are developing, and we are setting it up in IISc. Right now, I've just shown you a single device. This is a smart LED, which is controllable through LoRa network, or the LoRa network, and this is the pole gateway, which is essentially a compute module, which is basically Raspberry Pi. It has an ONT, an optical network terminal, and capability for adding additional hardware out here. So the way these poles are connected is through a GPON fiber network. GPON is basically a gigabit passive optical network, and this technology basically allows one to use the same fiber core and have multiple sources, optical sources, and producers and consumers of data. So it allows you to efficiently use fiber cores, which are which are finite in number. So you have, for example, you have this pole, 50 poles out here. Some of the poles have the fiber connectivity. Then you have passive optical splitters through which you couple the light data in and out of this fiber loop out here. And the fiber loop terminates out here in a device called OLT, optical line terminal. And then attached with that are these edge nodes for storing video data, for example, other sensor data. You can have proxies, network servers, etc., etc. And besides the Wi-Fi capability in these poles, you also have, because not all poles might have optical or Wi-Fi connection. Some poles might only have LoRa or long LPWAN type connection. And here we are looking at LoRa as the current technology, but it could be NB-IoT or one of this upcoming, any other IoT, long-range IoT technologies. And then you have other devices which are not on the poles, but in nearby buildings, on the roads, like garbage sensors, parking sensors, etc., which are also connected to the low bandwidth network. The point here is that we have a heterogeneity of networks. We have fiber, we have Wi-Fi, we have LPWAN, and we have to kind of work with all of these network technologies at the same time. So when you look, the middleware which we described earlier is actually realized through pretty much open source components which are easily available, except for one place. I'll just explain what that is. So what we have is of course our AAA current. This is just our implementation. If, others might have different implementations. The important thing is actually to agree on the APIs which access this particular middleware. How you implement it, there are many different ways. So this particular implementation, we are using LDAP as the store directory for storing all the AAA information. The catalog is built on top of MongoDB. The broker is essentially a message broker which is built on RabbitMQ, which basically uses RabbitMQ. The data store is on Elasticsearch. There's a geo server which serves GIS information, and video broker is made out of Wowza, which is not, which you can get free licenses for a limited number of licenses and limited functionality, but it kind of at least gets you going. And what frames this whole middleware is Nginx and Kong, which allows you to actually manage the API access to the to this whole middleware. And then one needs to do some stream processing of the data coming in, which we do using the Storm from Apache. Now, based on the kind of devices which are sending, you might require adapters, which again we build using either Node-RED or Storm. So this is our implementation of this middleware. Which is ongoing currently, there is a public version of this available with the APIs exposed, and we'll make it available for people to experiment and play around with, and access some of the data and IoT data which we have in our testbed. This is the kind of LoRa setup we have right now in the campus. So again, LoRa, fortunately, you can get all these low-cost gateways and the software which is open source, so you can actually put together your own LoRa network, which is very convenient. So our end nodes are right now streetlights. We have water level sensors built on LoRa, and we have some plans to build other sensors on and have LoRa on them. As I mentioned, the devices communicate with the gateway through using this Google's protocol buffer as the format. And so this is the LoRa wireless, and then behind this is the LoRa WAN on an IP network out here. And the adapter, which is built on Node-RED currently, which will migrate to Storm, pulls out the data using MQTT, but on the other side pushes data into the middleware using JSON, and according to the schema which I described earlier. So the way the flow, one of the important requirements of this middleware is that they should be, we need to know who's connecting to the middleware, what kind of access rights they have. And eventually it should be possible for the cities, for example, to monetize out of this. Just kind of a cartoon representation of how authentication and authorization happens. A user comes in and talks to the owner of the middleware saying, okay, I need access. And this happens offline, verification happens, and they get the API key. Once the user has an API key, the user can onboard multiplicity of devices and applications on their behalf. For every device or application, they need to say what resources they want to access. For example, it could be a streetlight, and they say, I'm going to push streetlight data. And then you get an API key for that particular, you use your API key, and what you get in return is an API key for that app or a device. Any future interaction of the device or the application with the middleware happens through its own API key. So the way the security right now is enforced is that interactions with the middleware happen on SSL, and the keys are managed by the certificate authority out here, and the APIs are protected by API key, which gets checked for authentication at Kong. And then every service which is running in the middleware uses the API key to check for authorization. Is that person or access allowed to do whatever it wants to do? And it uses the API key. And that information is stored in LDAP. And then it allows, either grants it or it refuses it. So, so what is apparent out here is that, of course, there's need for standards at multiple layers, but at the bare minimum, at least at the point, we want to be able to kind of interoperate and plug in different IoT devices from different vendors. And so there has to be a common format, so that I think everyone agrees on, and somehow one needs to evolve standards based on that. And we have kind of used JSON-based schemas, and this is something which even OCF, Open Connectivity Forum, has done. course, the schemas we are kind of using is a little different from them, but the concept and the ideas are the same. Not only at the schema at the middleware layer, but even at the lower layer, when I remove a streetlight from, say, Philips and put in a Bajaj streetlight, it should work right away. I should just be able to connect in and it should work. And for that we need standards at the wire or air interface, right? The way in which the data gets sent, and the data from vendor A should be, or vendor B should be, interpretable and manageable. The device should be manageable by third-party software. The accesses to the middleware via APIs have to be, again, kind of common and agreed upon, so that there is application and device portability across different cities in the country. So my application to manage Streetlight or get information about available resources should work whether I'm in Bangalore or in Chandigarh, for example. Finally, we need to have information models for Indian cities. So this is kind of important if we essentially want to get to the next level of intelligence of smartness, where applications are able to automatically infer and do things and help the administrators in a smarter way. And for that, we need information models, and these are very unique to every city, every suburb, perhaps every organization. And you know, and this is something where, again, we need a kind of a community to come together and develop these information model for the Indian cities. So the last but one slide, you know, this is of course something which is we have been working on with a very large group of people, both in IISc and outside. In IISc, we have a large team I mentioned out here, and we have had very good collaborations from companies with whom we are interacting, like MapUnity, Tejas Networks, Wipro, Bosch. Then we have a very large volunteer group called the IoT for Smart Cities Task Force, where many of the discussions have happened. And then, of course, we are also working closely with Electronic City, which is a township close by, and LCITA is the administrative unit of that particular township. They have kind of given us some practical perspective and also offered us space to do a test bed there. With that, I come to the end of my talk. I thank you for your attention. I'll be happy to take any questions.
So thank you very much, Professor Bharadwaj. It was an excellent presentation. I think you did a great job, much like a good professor. And I already have 2 questions, and there are some questions which are coming out from the participants. First of all, I would like to know that through the project, that we have an interest in organizing developer events and hackathon. How it working? That is my own interest that I would like to know, given that you have talked about all this test bed.
I'm sorry, I was kind of losing your voice. So your question is, how can the testbed be used for conducting a developer event? Is that your question?
Yeah. So what I'm saying is that you started with your presentation about putting people in the center, and
right.
So I want to know what kind of community events or what kind of challenges that you think developers could solve on such test beds. Any thoughts on this?
Okay. Yes. See, actually, I think the test beds like these can serve many purposes. Besides educating the people, the city administrators, having developers come in and kind of learn some of the technologies. But also, as you correctly pointed out, these could serve as spaces to create new solutions, and that is something which we are very keen to do as we go forward. We want to hold hackathons, developer events, where hopefully specific problems are posed, and and these are reasonably realistic problems, and hopefully the developers can prototype solutions and showcase them. So that is very much on the cards, and we are hoping to do that once we have a stable.
Right. So as you know, Professor Bharadwaj, that we started late, so we already have run out of time. But there are some questions from participants that I hope you could take up. So there are not many, but I have been assigning them to you. So first one is from Trinidad and Tobago, from Mr. Christopher. So he's asking, how critical is interoperability? Has India identified pivotal points, and what processes are being used to assure interoperability as smart city becomes more pervasive?
So there are two questions. One is how critical is interoperability, and I think it is extremely critical to enable low-cost solutions. And what is happening right now, and this was something which was explicitly asked for even by the city administrators, and not only interoperability of the devices, but also the pieces of software. See, the other big problem is you get locked into proprietary software, right? So, even that, if one can kind of make it agnostic to as much as possible, it may not be completely possible. So that is really important for long-term, low-cost sustainable solution. Now, the second part of the question is, has India identified pivotal points and processes? What processes are there? Unfortunately, I cannot answer that question actually, because I have not been involved with actual smart city implementations because we have been working on research test beds. But my suspicion is that we are not there yet. And that is where we have the standardization organizations like BIS, Bureau for Indian Industry Standards. We have TSDSI. They're all working on to identify these pivotal points and interfaces. But it is work in progress, and we are still in very early stages. The second question is from Naval saying, is the Streetlight catalog hosted on GitHub? Yes, the answer is yes, and we'll make it very soon publicly visible. Both the Streetlight will have a middleware instance also publicly accessible, so you should be able to play with the devices, etc., and then even cameras and so on. So we are working on that. There's one more question from Raghavendra Ramachandra on, could you please comment on the security level of the middleware? I'm not sure about what you mean by security level. Is this some levels as given by the US NIST standard by any chance? If that is so, I don't know. I don't think we have done any kind of certification for the middleware we are working on. And in fact, we'll be happy to collaborate with people and other experts in security to kind of look at how we can have a really secure system. So those are the three questions I have seen here on the dashboard.
Yeah. So there was a comment by Mr. Kishore Narang. I think he's involved, in this standardization process. So he wants to probably say that he can answer that, but maybe in that case, because there is a limitation of time, I point participants who are interested, maybe contacting Mr. Narang for his BIS position on this. But Professor Bharadwaj, one parting comment before we conclude this today's presentation, that I was recently making a preparation for this smart city material, and I found one project by Horizon 2020, which is a research project known as Espresso. So I don't know if you have heard about it. So they have some 37 deliverables in their project for this, and one of them is the ICT standards map that they have produced. So maybe I'll put that in the chat link, and maybe it is useful to your work and the other participants who are interested in knowing more about it. And I think there are a few more questions coming, so if you have still a couple of minutes, do you mind answering?
Yes. So there's one question. There's a question by Mukesh Dhingra on how do you ensure that research done by IISc is being extended across new city implementations. So we have been kind of advocating to the government, to whoever listens to us, that we need to set up these test beds in every city. And the reason is that I think, see, these are things where none of us really have that experience yet. You know, I mean, this is a new concept in some sense, so it just happened over the last year. And you know, we don't just become experts like that. We really have to experiment, play around, and learn. And also, one of our purposes has been that, look, these are not rocket science in some sense. You know, I mean, there are a lot of open technologies available where we can actually use and get going and learn what's going on. So our proposal to the governments has been that, you know, please allocate and create test beds in every city. These could be, you can identify 2 streets, 3 streets, whatever it is. It doesn't cost that much. Involve the local ecosystem, the universities, the companies. Let them get together and set up this test bed, run this test bed. And that place could also become the place for, you know, things like, I mean, exploring new ideas, new concepts, place for learning, capacity building, as well as interoperability test bed. You know, if someone wants to come up with a new solution, come and show it to the test bed, show it working with the existing systems. So this is something we have been advocating, and we'll be happy to work with anyone who, you know, and share our experiences in setting up these test beds and help get that going. So that's what we can offer from IISc, and of course most of the work we're doing is open source. We'll make that available, and publications and all that will be there. So hopefully, you know, that's kind of what we can do right now from IISc side. So there is a question from Pratik Varshney. Why are we not talking about standards like 1 M2M here, where interoperability is a need of ours? So I kind of alluded to in one of the earlier slides about this separation of concerns, about separating out managing data versus managing devices. And clearly, you know, we need standards all across. And 1 M2M is essentially been built to address, in fact, it kind of cuts across both device management. It also has aspects related to network management as well as data management. Right? So it's kind of cutting across all 3. And so that could be a possible standard, and it's for industry to converge around a specific standard, whether it's 1 M2M or whatever it is, and then kind of go ahead with that. So clearly standards are required for interoperability.
Professor Bharadwaj, I think
there is a comment from
one.
Yeah.
So I think there's one more question from Christopher, and Naval is making a comment. Can you?
Yes, yes. So Christopher actually has a comment. He's saying there is a NIST, National Institute for Standards and Technology from US, has a smart city framework. He says it's a very good tool to assist. It's well presented and it has great insights. So thank you, Christopher. We'll look into that. Yeah, we are in touch with some of the people in NIST, but you know, we haven't actually kind of worked together yet. But yeah.
So I think Naval is asking, can we create a community or a newsletter to stay in touch with your latest updates? So I don't know whether you have a mailing list or something that you want to advertise here, but I believe
that's a good suggestion, Naval. We can take that up. Yes. Yeah.
Okay. So I would like to thank you officially again, Professor Bharadwaj, for taking out your time. I think it was a very well done presentation, and also in the scope of the project, as I said, that, you know, we are very well interested in building the community around you know, the work that people like you are doing, and, you know, through developer events and hackathons. So I'm sure that our paths will cross soon, and we will have an opportunity to work together. So thank you once again. Thank you also the participants joining from all over, and we look forward for having you again in the next webinar. Thank you.
Thank you.